All right, good morning, everyone. So today's all about malicious code and application attacks. So this is the last lecture of the semester. We've covered all 21 chapters. Hopefully you paid attention and learned something. All right. So just a recap of the rest of the semester. We have the final labs on Monday and Wednesday. Make sure you come on your assigned day. Apart from that, let's see. Friday's an optional review. Let's see. Who's going to attend the optional review? Anyone? Okay, one person. Well, what I was thinking about doing, you all have a lot of stuff going on. So, how would you all feel if I just made it on Teams? Just send out a Teams link. That way you can still interact. But, you don't have to attend by any means. Is that good? That's good. So I'll be off campus Friday then. Probably play on my puppy or something. Who knows? That's probably what I'll be doing though. So yeah, like I said, we got the lab. It's gonna be a good one. I'm installing some virtual machines of Windows XP. Old classic, Let's attack it. Does that sound fun? Okay, so that's pretty much the end of the semester though. What I'll do for the final, I'll make it online, open book, open note. I'll also make it available the entire testing window. Is that cool? So having said that, make sure you take it. If you don't take it, guess what your grade's going to be? A 0. All right, not in the class. You could probably, let's see, I think the exam's 20% of the grade in here. Is that right? You can still pass. But you won't pass well. So why not take the final? I'm pretty sure I have to technically give 2 hours to take it. Whatever. It'll be 20 questions. I don't think you'll need 2 hours to answer 20 questions. Maybe you'll surprise me. I doubt it, though. Anyone going to take 2 hours to answer 20 questions? Multiple choice? Well, let's try to not take the full 2 hours. But like I say, it's on your time, so hey, take the full 2 hours, doesn't matter to me. Anyway, any questions about what we're doing the rest of the semester? Okay, so today we're going to start off talking about application attacks. We're going to talk about injection vulnerabilities. We're going to cover exploitation. We're going to talk about application security controls. We're going to wrap up by talking about secure coding practices. So before I jump into the content, I want to make note that the textbook actually has malware covered in chapter 21. However, malware was covered in a previous chapter, and it was also covered in the networking class. So I kind of skipped it, all right, because we've already covered it at least twice. I didn't feel like covering the same thing over and over. Okay, so let's talk about application attacks. So an application attack occurs whenever you have some application. It could be any application. It could be a web application. It could be a desktop application. It could be a mobile application. It just occurs whenever someone takes advantage of a vulnerability in the application. And typically it's going to be a vulnerability in how the application is designed and coded. Okay? So, for instance, you have the buffer flow attack, or buffer overflow attack, rather. Okay, so what happens there is some predefined buffer, which is basically some predefined amount of space allocated to something. Well, what happens if you don't have protection of that buffer is you're going to have a buffer overflow. Okay, and that can have various effects. There's not one single thing that will happen. It's going to depend on many factors. But in general, this could be used to do stuff like crash an application. So let's say that we had an ERP system and someone did a buffer overflow attack on it and it crashed the system. Which aspect of the CIA triad would that affect and why? Availability, and why? Because no one can access it. Exactly right. It's not the only thing you can do with a buffer overflow. Do a lot of stuff. Okay? But that's probably going to be the most common. Okay? So time of check and time to use. It's going to be pretty similar to some other tasks we talked about before, where what happens is at the time of check, there could be a delay between that and the time of use. And in the time of that delay, it could be, just a few milliseconds even. You don't know. But basically some malicious piece of code could inject itself in that time. Okay? So think about the time of check being the time in which it receives authorization versus time of use, the time it actually accesses something. Okay? So in that little window there, you could hypothetically perform an attack. Okay, backdoor. It's going to be a lot more common than time of check, time of use. Let's face it. A lot of programming, especially on cheaper devices, is done to, for what purpose? Talking cheap devices, think about strategy. So if it's a cheap device, the company's probably using which corporate strategy? Cost leadership, exactly right. Okay? And if you're using cost leadership, are you making sure that you don't have any backdoors in your systems? Probably not. In fact, you probably do. All right, let's face it. Backdoors are very common on a lot of IoT devices. They use hard-coded credentials. So they put in a username and a password. And the idea is that's supposed to be used for support and diagnostics. That's what they say. What are the downsides, though? So if you own a device, you have it. Let's say that it shares the same default credentials, and not even default credentials. Let's say it has an admin account, same as every other type of device, or every other piece of that, not piece. What am I trying to say here? Every other model of that device. All right, does that make sense? Let's say by a cheap security camera, they have 1 million different cameras of the same model, and they all share the same admin credentials. Okay, all you gotta do, you got the device right in front of you. It's not too hard to crack a password. Like Ron said, once you get that password, you can access any of them. That happens all the time. In fact, the United States government says you cannot use certain brands of cameras inside of not only federal facilities, but federal contractor facilities. I'm not stating whether I think that's right or wrong. Let's back up a little bit. Say we are using insecure cameras. All right. Is it possible to have the cameras be able to communicate with, say, an NVR and not be able to communicate with anything else? How would you do it, Ben? Okay. And specifically, what you would probably do further than that is on the router, you would probably disallow any packet transmission to any address that is not going to the NVR. Okay. And theoretically, you should trust your NVR, right? So you all know what an NVR is, right? Someone tell me what an NVR is. Network video recorder, exactly right. All right, so the idea, so this contrasts with a DVR. Okay, so DVR, talking about non-IP cameras. All right, still video recording technology, but wildly different. All right, so most likely, if you're talking about a DVR system, you're probably talking, well, in the context of cameras at least, you're probably talking about having analog cameras. All right. because most likely you're probably using some coax cable to communicate with them. Okay? So, going back to the discussion about backdoors, does that policy make sense to say you cannot have these vendors? Who says it does? Okay, who says it does not? All right, let's debate it. Ron, state your case. Yeah. And let me back up a little bit. That's not the only thing that's going on with these cameras. If you were to give them unrestricted network access, I'm just going to be blunt. They send a lot of packets to China. All right. So, Ben, debate it. Okay. And that would probably work fine for a large company, right? What about a small company? Okay. Well, again, there's no right or wrong answer here. I'm certainly not here to say you should take this approach. I'm not here to say the government did the right thing. I'm not here to say the government did the wrong thing, for that matter. A lot of different perspectives on it, right? So, I will say that I think that both approaches are valid. I see the benefits in both. Okay, however, let's be honest. All right, if you're buying an Axis camera, you're spending at least $1,000 per camera, right? Can that money be spent better elsewhere? Where would you spend the money, Sydney? Okay, like what? Okay. What else would you spend it on? So you're saying there's a variety of things other than, and $1,000 for an Axis would be pretty cheap. All right. So, kind of got off topic a little bit there, didn't I? All right, that's talking about backdoors that are very common in IoT devices, and it's in a lot of devices as well. For instance, closed source software. How do you know if it has a backdoor in it? Well, with closed source, you can't necessarily know for certain, can you? You can look for hints, though, right? What would some hints be that may indicate there's a backdoor? Why would rapid development indicate a backdoor may be present? Suppose that's possible. Not what I had in mind, though. So it has to do with analyzing something. You can't analyze the source code, can you? What can we analyze? There's a couple things. Name one. That's a big one. Network traffic. Look at who and what is being shared from the application. If you have an application that's real chatty, sending stuff back to servers, that could probably indicate a backdoor. Look at the packets themselves. All right. What do they have in them? You know, what's the other major thing we're going to look at when we're evaluating applications? Closed source. Give you a hint. You know, you'd probably do this in a sandbox and look at the changes. Okay, would you not look at the behavior that it does when it installs? See which registry files it modifies, updates, creates? Would you do that? Would you look at what it accesses when it's running? You know, is it accessing stuff that it doesn't need to access? A lot of behaviors you would look for. All right. So that may indicate a backdoor. It doesn't mean there is one, but may indicate there is. Okay, finally got privilege escalation and rootkits. It's privilege escalation. Obviously, that's pretty self-explanatory, I think, okay? You have some amount of privilege, okay? It's going to escalate it. So it's going to request to have more privilege. Why might that be a bad thing? Why might it be a bad thing for something to use privilege escalation? Something malicious. It's not a trick question. Say that someone wrote a piece of malicious software. Why would it be bad if it gets administrative access? It's malicious. You don't know what it's going to do. It can do a lot of things with administrative access it can't do with standard access. That makes sense? Rootkits. All right, rootkits are going to be a specific type of malware. It's going to lodge itself into system files. And it basically makes it nearly impossible to remove. Okay, at least remove without wiping everything. But having said that, you know, I would make an argument that it's probably easier and quicker to just wipe anything, regardless in an enterprise environment. All right, who disagrees? Who agrees? Why do you agree? Yeah, exactly. Okay. So in general, you know, that probably makes sense. And honestly, you get some weird issue with something, just wipe it. You know, don't spend 2 days trying to figure it out unless it's widespread. You got a single issue. Why would you spend 2 days trying to solve something when you can just wipe it and be done in 30 minutes? Who's got an answer? There's not an answer, is there? Unless you're just curious and, you know, you have nothing else to do. That's pretty unlikely, though, in the professional world, all right? You got 2 days to just sit on your thumbs, solving one thing. I don't think that's too likely. So, let's go a little bit more specific. Talk about injection vulnerabilities. So, the name injection would imply what we're doing here is we are taking some application of some sort. You know, we have 3 examples up here, of course. And we're basically inserting code snippets that it doesn't expect. Okay, so in the case of a Sql injection, we've talked about these before. Basically, you have a Sql server and you have user input. Okay, so maybe the user can input their first name. All right. Markers are scarce around here, aren't they? All right, so you're inputting your first name. And a normal first name would be something like this. Okay? Does anyone disagree that's a normal first name? You get an F in the class if you disagree that's a normal first name. I'm kidding, of course. You can have whatever opinion you like. All right, that's a joke. But what about this? Is that a normal first name? Why not? That's what I'm going to name my firstborn. Okay? I think that's a normal first name. So basically, I of course don't think this is a normal first name. Not going to be my firstborn's name either. But you get the idea. What's happening here is a SQL injection. You have an input field, and what we did, we used a good friend the semicolon. Okay? Good friend the semicolon ends whatever statement we're in, right? So likely what is happening on the back end is it says insert into person, and then it has whatever this field is called. So I'm just going to put a blank there. All right, but what happens is we did a semicolon, and then if we keep typing commands, it's going to drop the person table. That's one example of SQL injection. Now, is this not pretty easy to protect against? That's why most times when you're uploading something, not uploading, when you're inserting something into a form, okay, it disallows certain characters. Almost always is going to disallow our good friend the semicolon. Some other characters too. Maybe a period. All right, possibly a comma. Because these are all things that SQL uses, right? So, if I cannot insert a semicolon, this whole attack doesn't work, right? Because if it won't allow me to put the semicolon in, and I just type in drop table person, okay, insert into person, drop table person, that's not going to work, is it? So that's what's happening with the SQL injection. Any questions? Yeah. Well, you mean like what's happening after I do this? You won't have the person table anymore. Well, I mean, you could also do select star from person. You can get everyone's social security number, for instance. I mean, there's a lot of stuff you could do here. If you have an insert field that is not protected. And by protected, I literally mean you just don't allow semicolon and a few other characters. That's all you got to do. Does that make sense? So it does whatever you tell it to. All right. Code injection is pretty similar. Okay. So instead of thinking in terms of SQL, think in terms of you have an application, probably a web application, doesn't have to be though. And what's happening is you have some input field, and you don't disallow certain characters. Depends on the language as to what those characters should be. Typically it's stuff that ends a line. Okay, so that can vary a little bit. Sometimes it's a semicolon, sometimes it's a period, sometimes it's just the end of a line. I mean, it really depends. Okay, but someone can insert whatever commands they want, and that can be kind of dangerous, particularly when you start getting into stuff like curl. Okay, because what curl does, that is to say curl, okay, you can insert a lot of code with a very short line. All right, so a lot of times when you're installing stuff on Linux, you'll come across curl. And that can be kind of dangerous to trust, because do you really know what they're actually having for the code. No, you don't. You're trusting that you're getting it from a legitimate source, but that can be dangerous. All right, and then lastly, you got command injection. So command injection obviously would happen in something interfacing with either command prompt, PowerShell, or terminal, depending on what you're using. And it's the same exact principle here. Okay? So you're just inserting stuff that's not intended to be inserted. Does that make sense? So in this context of command injection, maybe you have something where it sends a shutdown command. It's not the most malicious thing ever, but it's annoying, isn't it? Okay, that could certainly happen. Anything can happen. That's the cool thing about this. All right, let's talk about exploiting authorization vulnerabilities. So we talked about these a little bit last semester in networking. All right, particularly in the context of session hijacking. Okay, so this is very similar. All right, so the first one I have up here is insecure direct object references. All right, and all that's going on here is we have a website. You see a little company name here, and then they have a directory that is, listed for certain files. So maybe this file is like a new user sign up file. But if you change this ID to different stuff, you could certainly access other files that you're not intended to access. So to avoid this, what do? Do you not just require authorization to access the sensitive files? Is that literally all you have to do? That's literally it. Insecure direct object references. I can't really think of a reasonable time where you would have this happen. Okay? Now, if you were purposely trying to set it up to be insecure, you could. But let's face it, you shouldn't have this be possible. Does that make sense? Directory traversal, pretty similar. All right? So basically what you're doing is instead of having a web address you're doing this with, you're doing this on a directory. Now, it would be even more egregious to have this be possible. Because basically, literally all you have to do is navigate through a directory, and you can access stuff you're not supposed to. Is that not pretty dumb? So again, how do you fix this? You have proper permissions, right? Use principles like role-based access control, least access, those sorts of things. Easily prevent this. To the point to where I don't even know that it's worth talking about a whole lot. And then lastly, you have file inclusion. It's going to be really similar to directory traversal. However, what you're doing is you're using the file to execute code. So most likely this is something like an Excel macro or something like that, where it can certainly use some code. Does that make sense? Most likely. Let's talk about web application exploitation. Okay, so you have several different types. Think back to when we had Corey talking with us. You guys remember Corey? He did an example of cross-site scripting. What did he do? Then what did he do? So let's back up a little bit. What is cross-site scripting? Cross-site scripting is simply, injecting something that you're not supposed to. Really similar to the injection attacks we just saw. However, the difference is, and this goes back to the example that Corey used. He set up a web application that was purposefully vulnerable to cross-site scripting attacks. All right, and then he had some level of protection because he only allowed a certain number of characters. I think it was either 16 or 80. I don't remember the exact number, but it was a small number. You can't do a whole lot in 16 or 80 characters. However, what he did was something similar to curl. Okay, it wasn't curl, but it was something similar, where he basically was able to have something that was able to point to something else. And from there, he was able to gain control of the website. So, it's not necessarily the most common type of attack, but it is something that can take place if you have ridiculously low amounts of security on your web applications. Okay, request forgery. What's forgery mean? You guys taking business law? What's forgery? Okay, so typically we're talking about forging a signature. Okay, very similar here. Okay, what you're doing is you're basically executing remote requests against some server. Okay, so basically, what happens is you forge the request. How do you forge a request? Well, there's a couple different ways you can go about it. If using low enough encryption for some of that stuff, you could certainly figure out the private key pretty easily. But let's say you're not. Can you use regular old session hijacking to basically steal someone's session token? And then with that session token, can you execute commands? Yeah, certainly one way. Okay, so that brings into session hijacking. All right. So, like I was talking about, the goal is to basically steal the session token. All right. A couple different ways to go about it. Most commonly, what you'll see is you'll see a man-in-the-middle attack, where basically it's going to impersonate a legitimate device, and it's going to steal the token, and then it's going to use the token. Now, that's not the only way to do it, of course, but that is most common. And with man-in-the-middle, we can pretty easily avoid it in an enterprise environment. Starts with a C. What can we do? Play hangman. That's right. All right. Use certificates. How would certificates prevent a man-in-the-middle attack, by the way? Exactly right. Okay. So, especially something like an access point. Does anything at all stop me from coming into campus with an access point and calling the SSID at Jerome? Does anything at all stop me from that? Nothing. What can prevent devices from signing on to it, though? It's up here. Certificates. All right, so you start talking about a lot of the different ways to do it. You should. Okay, because if you don't use certificates, literally nothing stops anyone from setting up an SSID. Nothing. You can broadcast it just fine. Now, granted, would the networking department probably be notified of that? There would probably be automated alerts in place, but they'd have to go physically track it down. It's not the easiest thing to pinpoint, is it? I could stick it up in a ceiling somewhere, couldn't I? I mean, sure, they would eventually find it, yes. Might take them a day or two. Who knows? All right. Talk about application security controls. How do we actually prevent application vulnerabilities from taking place? Well, I think the best answer is going to be good coding practices. That includes good coding itself, and probably more importantly, it includes good application review. So we talked about that. I think it was either last chapter or the chapter before. Talked about various ways to do that. All right, but let's think more generally, or more specifically. Input validation. So input validation would, number one, help with integrity, right? If you're validating that input is correct, it means your data has more integrity. Those two go hand in hand, right? What else does it help with, though? Okay, error prevention, exactly. That's another thing. Okay, now, are errors unavoidable to an extent? If you have a pretty substantial application, are you going to have errors in it pretty much no matter what? So what about proper error and exception handling? Are those not vital as well? So let's face it, when you come across an error, you don't want to crash the whole application, do you? What do you want to do instead? You want to catch the error and you want to have some predefined thing happen. Probably an error message, right? What else is input validation bias? It allows to prevent injection attacks. Again, literally, all you have to do to prevent Sql injection, disallow semicolon. That's it. Is that easy to do? It is. Web application firewalls. So basically, a web application firewall is just a firewall for your web application. I think that's pretty self-explanatory. So most of the time, this is going to come in the form of a DMZ. All right. Who remembers what DMZ is from last semester? Okay, so demilitarized zone, which means it's outside the corporate network, right? So let's say this is a corporate network. Okay, and then we have our web app. Now, in almost every case, a web app is going to be accessible outside the corporate network, is it not? So we have outside. What do we want to put in between here, though? So DMZ, and to enforce the DMZ, how do we do it, though? I think the DMZ would actually probably go here, now that I think about it. But, you know, most likely, we're going to be putting what right here, though? I'll give you a hint. It's up here. Okay, a firewall. All right. And the reason DMZ goes between the corporate network and the web app is because we presume that there's going to be the ability to traverse here. Does that make sense? We don't want to be able to traverse from the web app to the corporate network unless there's authorization. So again, it's going to be enforced by a different firewall. Does that make sense, Ron? Okay. So that's what's happening there. And this firewall is going to serve a lot of different purposes. Most likely, it's going to be used to allow us to drop packets we don't want. So, you know, let's say you want to drop an entire country's packets. Can you do that with a firewall? Easily. Why might you want to do that? Okay, let's face it. Let's say your country has sanctions against another country. I'm not going to mention any specifics. You can leave that up to you, which country you don't like. All right? So, you know, it's very easy to say we're not doing any business. We're not even going to let them access our internet. Should you do that? I'm not here to say. I think it's a very deep ethical question. Probably a moral question. All right? And again, I'm not here to preach to you. Does that make sense? I'm just here to say you can do that with a firewall easily. All right. You can also block anything malicious. You can do deep packet inspection, make sure that everything coming in is what it says it is. A lot of advantages of having a firewall right here. Does that make sense? Okay, database security. I feel like we've talked about that a good bit. So, it's a review. What is one thing we need to do to secure the database? Input validation. What's another thing? Okay, restricting permissions for stuff like editing, viewing, inserting, anything like that. You want to make sure everyone has what they need, but not anything more than what they need. What else? It's an important one. It's kind of how we secure anything in security. Encryption, yeah, that's a big one. But sort of more generally, we'll use this hang thing down here. Starts with an L. One guess the letter. I think you all know the answer. I hope you all know the answer. Layer. Okay, exactly. You want to protect every layer. Like we talked about, probably at least a dozen times in here. If any single layer is not protected, that can be how you're exploited. Does that make sense? So think about everything for securing a database. Lastly, code security. I feel like we talked about this a good bit as well. All right, in fact, I feel like we just talked about this even. So, just with everything else, you want to secure every layer. You want to have good review. You want to have good coding practices. You want to have good comment practices. You want to have good exception error handling, good input validation, good everything. All right. Oh, we talked about it in the next slide. I knew we talked about it at some point today. All right. I guess I'm living in the future. Okay. So comment your code. How does that help with security? Y'all have written code before, right? Why do you comment it? So the next person, but even so you remember a week from now. If you don't have it, it's going to spend a lot more time trying to correct a problem. Let's say that problem is a vulnerability. Error handling, we talked about hard-coded credentials, we talked about memory management. Why is memory management important? First of all, let me ask a simple question. Is memory finite or infinite? It's finite. So why is memory management important? Okay, so in general, if you have a finite resource, like you were saying, you don't want to use more than is needed. Okay, because that costs money. It costs money to increase these costs, makes you less competitive. If you're less competitive, your revenue will likely go down, although not always, but we're going to assume it will for this example. What happens to your profit? Imagine if you had to buy 512 gigabytes of RAM to use Canvas. Okay, just imagine. It feels like that some days, doesn't it? I can complain about Canvas all day. That's not what you guys pay for, though. Let's just say that you had to have that. Are there desktop computers out there capable of supporting 512 gigabytes of RAM? Yeah. Are there laptops out there capable of it? I don't believe so. I could be mistaken, but I'm not aware of any. Okay. I know the P1 allows, I think, 128 gig. That's a ThinkPad. It's a performance model. I don't know. Someone look it up and see what the most RAM they can find in a laptop is. I'd be surprised if it's above 128 gig myself. Not saying it's not. I'm just saying I'd be surprised. But desktops, we can easily have workstations with over 1 terabyte of RAM. What's that going to cost, though? So first of all, there's no portability. Portability is out the door. There might be more than 128, but I'm not aware of it. So, let's just think about this. Everyone had to buy a workstation. Okay, first of all, workstations start around $2 to $3 grand, right? And that's for a very base specification. So to spec up like a Precision or a Z series or a Think Center, to spec one of those up to 512 gigabytes of DDR4 or 5, ECC, of course. What's that going to cost? At least 10 grand, right? You want to spend 10 grand to access Canvas? Huh, joke's on you, in a way you do, don't you? I really shouldn't make jokes like that. Huh. You know what? Nothing can stop me. All the way up. Okay? So, memory management's important. Not just for that, though. Because, the cost is a big deal, but let's back up a little bit and see what happens if a system runs out of memory. Okay, so let's say you run out of RAM. What is your system going to do? Page file. Exactly right. What if you run out of page file? You run out of disk space. What happens? Is your system just slow to a crawl? Can it potentially blue screen or kernel panic, depending on what you're using? Can. Okay, most likely, though, it's just going to slow to a crawl and switch stuff in and out of memory as needed. Memory management's important. All right, so just to wrap stuff up, it's the last lecture of the semester. Had application attacks, injection vulnerabilities, exploitation, application security controls, and secure coding practices. Any questions? All right. Good luck on everything. Finals, whatever you got. I'm assuming you all have finals. Actually, I know you have at least one. So good luck on it. Don't sweat it too much. You got 2 hours for like 20 or 25 questions, multiple choice. There's really not a reason to not make an A, to be honest with you. Yeah, I'm just going to leave it at that. You can figure out what I mean, I'm sure. I should probably stop the recording.